Alrighty, welcome to 11.3. Section 11.3 is talking about the shapes of the distribution. Um, we're basically just going to be talking about what do the graphs look like. And we're also going to talk a little bit about making a histogram because we haven't really talked about that before because I know that you have to do that on some of your homework. So, first of all, this is a histogram. Okay, a histogram is like a bar graph, but instead of, there's several things that are different. First of all, a histogram, so a bar graph we don't really use to measure two quantities that are quantitative. In other words, we don't really use histograms or bar graphs, excuse me, to talk about things that have two numerical values. We normally only use bar graphs if we're like counting things that don't have a numerical characteristic. So like something we might use a bar graph for would be, you know, everyone's favorite color. So if you went and you surveyed everybody's favorite color, you would have 10 blue, 6 green, 3 red, and then you'd make a bar graph. Histograms are a little bit different. We use histograms similarly. We count the frequency of things the same way, except that now you notice that they are touching, which in bar graphs they're not, and also we can use them to measure two types of quantities. So we might ask how many people study in between 10 and 15 hours a night. Okay, so we'll talk about that a little more here in this first example, but that's what a histogram is. So these are the histograms, and we're going to be talking about the shape of them. So if you have a histogram here that has a tail end over here on the left, and a lot of the data is over here to the right, that's what we say is skewed left. Okay, so the way that I kind of think about it is the tail is to the left. Okay. And so what that means is that because the tail is over here, that means there's a bunch of data on this side. Okay. So what we say is that most of the data is on the right. Okay. And because of that, what's going to happen? Okay. So remember, the median is the middle number. The median is going to be about here-ish. Okay. And because there's a lot of numbers, the mean, what's going to happen is you have like a lot of numbers over here that might be a little bit bigger, but you also have some numbers down here that are pulling that mean down. And so your mean is going to be somewhere on this side. Okay, so because of that, we're going to use the median if we're skewed. And we've talked about that already a little bit. Okay. If it's symmetric, that means it looks like an actual bell curve. It's not skewed one way or the other, okay? And so what I might say here is the data is what we call, I'm going to put it in quotation marks, normal, okay? And sometimes we use this, not very often, but we might say a mirror image, okay? And when it's symmetric, we use the mean. So if it's skewed, we use the median. If it's symmetric, you use the mean. Okay, that's just because when you have data, pulling one way over the other, your mean is going to be affected way more than your median. We've talked about that a little bit in class already. Okay, and so skewed right is basically the same thing as skewed left, except now the tail, so I'll put that in quotation marks, the tail is to the right. And so most of the data is on the left. And so again, we're going to use the median. Okay, so that's the shape. So we're going to spend some time looking at some graphs and just talking about the shape of them and then which measure we're going to use. So let's look at an example. A police officer measures the speeds in miles per hour of 30 motorists, and he organizes it in a table. So these are all the speeds that he caught. The results are shown, and we're going to fill in the frequency table. Okay, so the reason we need to fill in the frequency table is because then we're going to organize it into a histogram here in a second. So we want to count how many people traveled in between 31 and 35, and I'm going to cross them off as I go. So there's one, nope, there's just one of those. Beautiful. Okay. So now in between 36 and 40, there's 1, 2, is my third one? I have three. There's one, two, where'd it go? I just saw it. Three. We count 40 because that's where it's included. So there's three people that traveled in between 36 and 40 miles per hour. 41 to 45. Okay, so there's 1, 2, 3, 4, 5 of those people. 46 through 50. Let's see. 1, 2, 3, 4, 5, 6 of those. 51 to 55. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And then everybody else went 56 through 60. So 1, 2, 3, 4 of those. Okay, so basically we just divided them up and organized them into different like groups. Okay, and so now you would be asked on your homework to create a histogram. Now I've already partially created one here just to save us some time. Okay, so what you would do is you'd make your boxes. Okay, the frequency is how often they occur, and I already drew my boxes, so we're just gonna fill in what should go down here. So you notice that there's only one person that went in between 31 and 35. So there's the one person, right? That's the frequency. And that was in between 31 and 35. Then this one was 5, lies, 3. I can't count today. 3, so that's in between 36 and 40. That one was at 5 there, so between 41 and 45. The next one was at 6, which matches our data, so between 46 and 50. That one there is the 51 to the 55. And the last one is a 56 through 60. Okay, and so this is the miles per hour. All right, so I think between that and just your knowledge of basic histograms, I think that you should be okay making some on big ideas. If you run into problems, let me know. Okay, so the speed limit is 45 miles an hour. So here's the speed limit, right? So all these people over here are speeding. And so how would you interpret these results? Okay, so there are exactly, let's see, there's 5, 6, 7, 8, 9. There are 9 people that obey the speed limit. Okay, and then so that means that there are 6 plus 11 is 17, plus 4 is 21, so 21 people speed. Okay, so, or you could say there are more people that speed than that go the speed limit. Okay, that's just, that question there is just asking you to draw a conclusion about what you already know. Okay, so emoticons are graphic symbols that represent facial expressions. They're used to convey a person's mood in a text message. You guys know this. They're emojis, okay? The double histogram shows the distributions of emoticon messages sent by a group of female students and a group of male students, okay? So we're going to compare the distributions. And then we're going to talk about which measures of center and variation that we should use. So here are the female students, okay? And so what this histogram says is that male students, they found 14 of them send in between 0 to 9 emoticons. So you can see 0 to 9 emoticons. 12 of them send in between 10 and 19. And then we'll just jump over here. Two boys send in between 30 and 39. And notice that not many people send a whole lot. Okay, but girls, on the other hand, are a little bit different. They send way more messages. We found 4 people that send in between 50 and 59 emoticon messages in a day. Like, that's kind of crazy. So let's talk about the female graph first. So for the females, okay, because, and I kind of like to draw this bell curve just to see that you could argue that it's slightly skewed left, but I'm going to say that it's symmetric. Okay, it looks more symmetric than it does skewed. So if it's symmetric, that means that we use the mean. So that's the measure of center, and the measure of variation that goes along with that is standard deviation. So if you're using the mean, then the measure of variation that you would use is standard deviation. Okay? So there's that. For the males, okay, if we were to draw a curve here, we can see that is absolutely skewed right. Okay? And so we're going to be using the median. And then on something like that, you could say using the range is probably a better variation than the standard deviation is. Okay? And so now what we need to say is, okay, so if we're going to use the mean, let's use the mean. So for the female, the mean is going to be somewhere in here-ish, right? That's about the middle of our data. So the female mean is 30 to 39. And then we decided with the male that we need to use the median. Okay, and so the middle number there is going to be probably somewhere in here-ish, right? That would be about the middle of our data. So the male median is in between 10 and 19. So the conclusion that we can draw from this, which should make a whole lot of sense to you, is that a female is more likely to use emoticons. Okay? So basically what we're doing is just, in this section, is just looking at graphs and determining what we can, say about them. So nothing too crazy. So why don't you go ahead and get started on that big ideas, and we'll talk a little bit more in class about some other things that might pop up that you might see. Okay? See you in class.